5-4, day 2. Gotta love day 2. Always seems to be a little simpler because we've already poured the foundation. So let's go. So look at this problem. Kind of weird looking. Let's talk about this. Talked about it on day 1, but I got to re-emphasize this. If I said, hey guys, square both sides, and you went, okay, square things individually, and then you thought about doing that over here. Is that a good move or a bad move? Well, a bad move if you did it like this. But that's no longer true. So how could you appropriately square both sides? Not individually. You got to group that stuff, square it, group that stuff, square it. Now, okay, how does that apply to this? Well, if a student went like this, square that, square that, square that, again, they wouldn't know it, but they just butchered it. It's not going to work, but you won't really see why unless they're numbers. But these represent numbers, so this is the rule. You just got to put that in your toolkit. Remember the rule from day 1. Let's get this thing alone before we square it. Well, it is alone, so we can square it. But if I'm going to square this side, you got to put parentheses around it and square it like that. Then it's true. You see? So this turns into 3x minus 2. This, now can I just square this and call her good? No, if you square a binomial, it's going to be x minus 4, x minus 4. Now can I FOIL? No, they're not conjugates. So I have to FOIL this. X times x is x squared. I'm going to go outside and inside. Negative 8x, negative 4 gives me 16. We're off to the races. We got a trinomial. Subtract 3x, add 2. Subtract 3x, add 2. Right. This is 0 equals x squared minus 11x plus 18. Is this factorable? Yes. So I'm going to factor that into x and x, 2 factors of 18 that add up to negative 11, negative 9, negative 2. So x is 9 or x is 2. Here's the thing. If you have a problem like this, 2x plus 6 equals 10, and you get x as an answer, you don't have to worry about it being extraneous. Extraneous means you got an answer that doesn't work. Whatever you get here will always work for something like this, but when you start throwing square roots in these problems, some funky things that happen. So here's a twist. You got to plug these possibilities back in. So if I put 9 back into the original, forget about those squares, forget about this. 9 times 3 is 27. 27 minus 2 is 25. The square root of 25 is 5. Equals 9 minus 4 is 5. Winner, winner, chicken dinner. Let's try the 2. 2 times 3 is 6. 6 minus 2 is 4. The square root of 4 is 2. If I put the 2 in there, 2 minus 4 is negative 2, and that's false, so that's extraneous. Doesn't work. You only get 9. Okay? Let's go into this one. Well, this is just saying some number to the 1/2 power. Remember what that is? It's just like, hey, the square root of some number is 6. And you can just use your head. Well, that's got to be 36. Well, let's try it differently. Remember, we're not done until we get x to the first power equals some number. Then we know our answer is this number. Well, that's 1/2. How can we manipulate this to make it a 1? Well, we're going to multiply that by 2 over 1, which is just 2. Then we got to do it here. These cancel, creating a 1, and then 6 squared is 36. You're going to need that little trick to solve these crazy looking problems. Looks impossible. 5/2 power, what the heck? Well, I'm going to get rid of it by multiplying by the reciprocal. Then I got to do it over here too. These cancel, so I'm left with x squared plus 5x plus 6. Now what's 1 squared? Well, that's 1. What's the 5th root of 1? 1. I got a trinomial, and we're out to the races. X squared plus 5x plus 5 equals 0. Let me just double check something. Thought something was fishy. This was supposed to be a 5. And I was wondering, because lately they haven't been forcing us to use quadratic formula. There are no two factors of 5 that add up to 5. So I figured something was a little off. So let's fix this. Just x squared plus 5x plus 5 equals 1. Now I'm going to subtract 1, wait. X squared plus 5x plus 4 equals 0. We're going, aha. Right. Now, you should know to use the quadratic formula, though, if it's not factorable. But lately, they're just giving us nice little factorable trinomials. So that's x. Two factors of 4 to the f5 would be 4 and 1. So my possible answers are -4 or -1. I said possible answers. So you just got to get in the habit of knowing they might not work. So I go back to the original problem. Give me 1 second. Okay, had to create some room there. So I took the -4, squared it, 16. -4 times 5 is -20. That 5 comes along for the ride. Clean this up. 16 plus 5 is 21, minus 20 is 1 to the 5/2 power equals 1. Well, we know that's true, because really 1 to any power is just going to be 1. So that's a winner. Now, let's put in the -1. -1 squared is 1. -1 times 5 is -5. Plus 5 to the 5/2 power equals 1. These 5's cancel, so I get 1 to the 5/2 equals 1. If you want to look at it fancy, this is the square root of 1, which is 1. 1 to the 5th power is 1. So all that's saying is 1 equals 1. So there you go, first problem. I stand corrected. It wasn't the first problem. That was the second problem. Now it's the third, last one from the pre-lesson. We got that wacky exponent. Well, get rid of it by multiplying by the reciprocal. I got to multiply that by the same thing. Take care of this side first. X plus 18 equals, now notice these cancel. So I get x minus 2 squared. Well, I got to go x minus 2, FOIL that out. Outside, inside, -4x. And then last, plus 4 equals x plus 18. Hopefully I wrote this one right. -x minus 18, -x minus 18, rank 0 is that showing up okay? X squared minus 5x minus 14. My black marker's dying on me. X, two factors of -14 that add up to -5 are -7, +2. So x is 7 or -2. Don't you dare put that in your answer spot. Check it out. 7 plus 18 is 25. 7 minus 2 is 5. Squared is 25. Ding, 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 ding. Put the -2 in. -2 plus 18 is 16. -2 minus 2 is -4 squared is 16. -2 minus 2 is -4. Squared is 16. Okay, that is your final problem from your pre-lesson.